What? Just broke one sit right here.
They're smiling on us now.
Get ready. We're so aggressive this morning. God. Can I not sit over there? You're my way.
This is my fucking life.
Can I sit there or not? I don't want to sit here. Can I move?
This
I don't want to. You're gonna move.
I remember this.
Yeah.
What kind of words?
Oh, this one has no carpet. I want to sit food. No. We all thought it was the same thing. We all said it exactly at the same time. And I was the only one who thought to change you guys.
No, it is the one.
I remember saying something.
There's just a lot.
Oh, yeah, it was just you and all four of us said the same thing. Yeah.
Mid-90. What's your question?
10.
Good morning, everyone.
Morning.
How's everyone doing?
I believe she was Friday.
Yours is Friday?
It is Friday. What are you talking about?
It's Thursday.
Really?
Yeah.
We have a quiz on Friday.
Yeah, it's quiz tomorrow.
I don't think it's though.
I think you can wait till Monday.
Alright, so we
We'll be
are
here Monday.
Exactly.
so we're gonna start going over interest today. So does anyone have any idea what interest is? What is interest?
It's like what you get back or
So it's what you get back when you put money into something. What else? Like taxes. What else? So who wants to buy a car someday? Yeah? So have you heard that when you drive a car off the lot, the value of the car depreciates? Yeah? What about baseball cards? Is anyone interested in baseball cards? No? So baseball cards have a value, right? And after so many years, they could be worth a lot of money. So they have interest on them. So what interest is it, you mostly hear about interest when it comes to stuff with money, like bank accounts, savings accounts, loans, like car values, baseball card values, stuff like that. So even student loans, there's interest rate on that, and let's pay that back for borrowing. So we have two formulas we're going to look at right now. So the first one is A is equal to P times 1 plus R over N raised to the N times T. So we've got different values in here. So our A value is our balance after T years. So it's our final value. Okay? Then T is our original amount invested. So you invest money into something, and that's the starting point. Then our R is our interest rate in decimal form. Okay? So if you have a or if you have a percent, you have to convert it to decimal form by either moving the decimal 2 places to the left or by dividing by 100. Right? Does everyone remember that? Yeah? Then the next thing is N is our number of times per year that the interest is compounded. So we have some different terms that we need to know here. So we've got annually. So if it's compounded annually, it's compounded one time per year, right? Because it's only once. So our n is 1. If it's semi-annually, then our n is 2 because it's twice a year. So, Nicole, do you want to guess what quarterly would be then? 4, right? Because it's 4 times a year. What about monthly, Jonathan?
Well,
So, yeah, so our n is equal to 12. Jacob, what would weekly be?
52.
52. Because there's 52 weeks in a year. So once a week it's getting compounded, so in 1 year it's compounded 52 times. Does that make sense? Yeah? So Robin, what about daily?
I'm so confused with how this is working. Oh, so okay, so how like the monthly, weekly, and daily is how many days are in a year?
Yes.
Okay, then 3.
So because it's that many times per year that the compounding is happening.
Okay.
Does that make sense?
Yes,
So
ma'am.
annually is once a year that it's being compounded. And if it's daily, then it's every day of the year it's being compounded, right? Does that make sense?
Yes.
Okay. So daily is, what was it?
365.
365. And then T is just the number of years that the interest is compounded. Now, we've got another formula here that's very similar, but there is a slight difference. So if it's continuously compounded, we use A is equal to P times E raised to the R times T. Where our A, P, R, and T are the same as from above. So A is our final, P is our original or our starting point, R is our interest rate in decimal form, and T is number of years. The difference is instead of using N inside of all of this, we're using E. It's important to note that E is a number, okay? It's a constant number, kind of like pi. Okay, so pi, we know is 3.14 rounded, right? So similarly, if we look at a calculator, there's 2 different buttons that we use for E. So the first one is if you see here above on the divide button, right above it there's a blue E, right? If we hit second, and then the divide button, it puts the E in. So this is E to the first power. And if we hit enter, we see what the constant term is. This is just like pi in the sense that it's an irrational number that's a decimal point that never ends, right? So no matter how much you do it, it's never going to end. So this is why we use E, is because we don't want to round it. To make it more exact, we use E just so it's exactly what it is. The other button is, if you look here next to the 4 button, there's a black button that says LN on it. If right above it has E to the X. So we can hit the second button, and then the LN button, and it puts in E and then raises it to an exponent. Is everyone following? So has everyone found those buttons? So those are the buttons that we use for E when we're solving the problems with E in it. So E is a constant term that never changes. So let's look at problem number 1. The amount of $500 is deposited into an account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? So the first thing we're going to do is we are going to write out our letters. So since it says compounded monthly, we're using the first formula. So we need A, P, R, N, and T. And we know the formula we're using is A is equal to P times 1 plus R over N raised to the N times T. So it says the amount of $500 is deposited. So that's our starting point, right? Since that's where we started with the deposit. So that means that we have our P value of $500. This means we are solving for A, our final value. Anyone have any questions on that? No? Okay, so we're solving for A. we have P. Our rate is 9.5%. We need to convert that to decimals, which would be 0.095. Then our N is how many times per year it's compounded. It says compounded monthly. So, if it's monthly, there's 12 months in a year. What is the balance in the account after 3 years? So that says that our T is 3. So once we get all of our numbers to the letters over here, we can go back to our formula and just plug them in. So we're going to rewrite the formula with the numbers plugged in. So we're solving for A. We have 500 times 1 plus 0.095 over 12 raised to 12 times 3. So now we put this in the calculator. So when you put it in, it should look kind of like this, right? This is what everyone has it look like. And then we hit the enter button. Did anyone not get this number? Everyone got this? Robin?
Oh, I forgot the zero. The space.
Give her a second. It's also important to note that in some of the calculators, you won't automatically have the exponent up here, so you'll have to put a parenthesis around the exponent to make sure it includes it. So, everyone got this number? Yeah? So, if it's compounded monthly, the balance in the account after 3 years is $664 and 14 cents. Also important to note that since we're working with money, unless it specifies, we're rounding to the nearest cent, which is also the nearest hundredth, which is also 2 decimal places. So does everyone remember how to round, right? Yes, Jacob?
When we enter it into the calculator, can we just do raised to 36?
Yes, you can also do raised to 36 if you know what, you can do that. The important thing is when you're working this out on stuff like homework and quizzes and tests, you want to see this. You want to see that you know how to plug it in. Now the next part says, what is the amount if it were continuously compounded after 3 years? So our T is the same, our R is the same, our P is the same. The difference is we're using the other formula, right? So we're using the E formula. So we plug our numbers in the same. So A is equal to 500 times E, and then we raise that to the 0.095 times our 3 years. So we want to plug this into the calculator. So 500 times, well, you don't need to put the times in. So 500, and then second, the LN button, so E, and then 0.095 times the 3 years. Did anyone not get this number? Is this what everyone got? Did you have a question, Brooklyn? No, you got this number? Yeah?
I thought I had to put it
Yeah, so some of you will have to use the parentheses around the exponent in your calculator because it doesn't put it like that, right? So if we put parentheses, You would put parentheses around the 0.095 times 30. Like that, right? Did you get the same answer? Yeah. Okay. So, if it's continuously compounded, we have $664.88. So, Haley, which would you rather invest your money in? Would you rather invest in the compounded monthly or the continuous? Which one's more? It's the continuous one, right? So even though it's only about 62 cents more, after 3 years, it still has more money in it. So in this case, we would want to invest in the continuously compounded one because it gives us more money. Any questions? No? Okay. But sometimes that will actually vary. So depending on how long, so if it's after 1 year, it might be that the monthly is worth more, but so it really depends on your rate and your time on which one you would want to invest in. So let's look at number 2. Your collection of baseball cards cost you $150 in 1988. In 1994, the value of the collection had increased by approximately 7.5% continuously compounded. What is the value of the cards in 1994? So, the first thing we want to note is it says continuously compounded, which means what, Jonathan?
The E.
The E formula, right? So we want A is equal to P times E raised to RT. So we need to pick out our numbers for here. So your collection of baseball cards costs you $150. So, and it's in 1988. So that's our starting point, right? Does everyone see that? So that's our starting point, which means we have our P and we're solving for A. So we start with 150. We're solving for A. So then it says that it's increased by approximately 7.5%, so that's our interest rate. So we convert that to decimal and we have 0.075. And then it says what is the value of the cards in 1994? So we're not specifically given our time here, but we can still find our time. Alan, how do we find our time in this problem?
You see when they were originally purchased and then 1988 and then in the question.
So we use the 2 years in the question here. So our final year is 1994. Our original year is 1988. So we subtract 1988 from 1994, right? So then what does that make our time, Alan? 6, yes. So was it really hard to find our time in this problem? No. So just because we're not given it directly doesn't mean we can't find it. So now we need to plug it into our formula. So, Isaac, what did you get for A?
Like $235.
Very good. So $235.25, right? Remember, rounding. Are there any questions? Okay, so if we go to number 3, how much would you deposit in an account that pays 6.25% interest, compounded semi-annually, to have a balance of $5,000 in 15 years? Jonathan, are we looking for A or P in this problem?
For what?
A or P? Are we given our
P.
initial? We're solving for P, right? And why is that?
We're given A.
Yeah, so we're given A because this is our final amount that we want. So after 15 years, this is how much is in there. We want to find out with these numbers how much we need to deposit to start out with. And Jacob, are we using the E formula or the other compounding formula?
The other one.
The other one, right? So A is equal to P times 1 plus R over N raised to the N times T. So we have, like Jonathan said, we're given our A. So, Nicole, what's our A? 5,000. We're looking for P. Brooklyn, what's our rate?
6.25.
So that's the percent. So how do we get it to decimal?
0.0625.
So 0.0625. And Robin, what's our N?
2.
2, right? And why is that?
I don't know.
What terms in this problem tells us that it's 2?
Semi-annually.
Semi-annually. So since it says it's compounded semi-annually, that means our N is 2. Jacob, what's our time?
15.
15 years, right? So now, the other two problems, we were solving for A. So we had all the numbers on one side of the equal sign. But now we're solving for P. So let's go ahead and plug our letters, like all of our numbers, into the formula, and then we'll look at it. Okay, so is everyone writing this down now? Yeah? So on the other ones, like I said, everything was over here and we were just solving for A. So I was just simple plug it all straight in the calculator. But now we have numbers on both sides of the equal sign. What are we doing to P over here with this number in the parentheses? We're multiplying, so that means that we're going to end up doing what? Dividing. So the first thing we're going to want to do is we want to solve for this. So let's go ahead and solve for this in the calculator, and then we'll go from there.
Do we add the exponent?
Yes, you want to add the exponent. So, is this what everyone got in the calculator? So, did you get it? Did you put something in wrong?
I did the wrong decimal spot.
Okay. So we notice here that this is a decimal. We want our final answer to be as exact as we can possibly get it. So we're not going to round this in the middle of the problem. Does that make sense? So, like we said, we're dividing 5,000 by the number that's multiplied to P. So, how we're going to do this with the exact numbers, we said 5,000 and divided by. Does anyone remember using this negative button down here with the A and S above it? Yeah? So, if you see above this button at the bottom here, there's in blue A and S. That means answer. What we're going to do is we're going to hit the second button. We're going to hit answer and then enter. So we should get this as our P value.
Wait, how did you do it again?
So the second button, and then down at the bottom there's the negative button.
Okay.
Right above it says A and S. You hit this button. It should put it in. So did anyone not get this number? Everyone got this number then? You good there?
No, we keep forgetting to divide our zeros.
Those are important. So we should have gotten this number for our answer for P. So in this case, P is 1,000 $986.33. So how do we, when we're dividing by the decimal, how do we get the decimal answer in there? Anyone? Second answer, right? So when we're solving for P, we always want to remember second answer. Now let's look at the last page. Unfortunately, not everything increases. So like we mentioned earlier, par values depreciate, so they're decreasing, right? So when we're looking at decreasing or depreciating, it's the same formula on the front, with the only difference being that we have a subtraction sign in here and not an addition sign. So it works the same. We plug in all of our numbers the same. All the values, like all the letters are the same. The difference is we are subtracting. So if we look at number 4 here, the value of a new $12,500 car decreases 20% per year. Find its value after 3 years. So, Jonathan, what tells us that we need to use the subtraction formula? It says decreases, right? So it says decreases here. We use the subtraction formula then. So we know we're using the subtraction formula, so we'll write that down. And we know we need to write down all of our letters. So Isaac, are we looking for A or P here?
Looking for A.
We're looking for A, right? Because we're given our P value. So what's our P value then? So 12,500. We're looking for A. And then, Alan, what's our rate?
0.2.
0.2, right? Because it's 20%. So, Brooklyn, what's our N? 1, right? And what tells you that? Per year. So, another important phrase or term here is it says per year up here. If it says per year or each year, that tells us it's one time a year it's compounded. So then, Robin, what's our T?
3.
3, right? It straight up tells us. We love it, right? So now we need to plug these into the formula. So we know A is what we're looking for. And we have times 12,500 times 1 minus 0.2 divided by 1 raised to the 1 times the 3. Now we know that anything divided by 1 is itself, right? And anything times 1 is itself. So I just put these in here as placeholders so we could see what was going on. But if you know it's 1, you don't necessarily need to put them in. So we'll put this in our calculator. We have 12,500 times 1 minus 0.2 divided by 1 raised to the 1 times 3. So, that's what everyone got? Yeah? So everyone's understanding how to plug these into the calculator? Good. So our A is $6,400. So after 3 years, and with the decreasing at that rate, our value of the car is $6,400. So it's one of the things we want to make sure is that our answers make logical sense.
Wouldn't that mean wouldn't the value of the car be 5,000? Because that's how much it went down. So 6,400. Wait.
So now this is, after this many years, this is what the value of the car is.
Okay.
We're not doing any we're not subtracting that from the original or anything. So as I was saying about we wanting our answers to be logical. So in this case, we had P, we solved for A, and we knew it was decreasing. With this, we knew that our original starting point was going to be greater than our final point, right? That makes logical sense. And if it was the other way around, if we had A and we were solving for P and it was decreasing, our P would be what? Larger. So it's very similar with we're doing some of the problems from the front. And when we solved for A and it was increasing, our P was less than our A. And when we solved for P, it was supposed to be less than A, right? So if it's increasing, your starting point should be less than your final point. But if it's decreasing, your initial point should be greater than our starting point, right? Does that make sense to everyone? Yeah? So some important terms that I want to point out here is when we're figuring out which of the two formulas to use that's not the continuously compounded one, we have terms that we want to look for. So if we're wanting to use the addition one, we want to look for terms like appreciate, increase, pays, deposits. Right? Because this means that the numbers are getting bigger as it goes on, right? So if you see any of these words, this means that it's increasing and that we want to use the one with the addition sign. That makes sense. Now, if we use terms like depreciate, decrease, or withdraw, that means our number is getting smaller, right? So if we withdraw an amount of money out of our bank account, we have less money in our bank account. Or if it's decreasing, it's getting smaller, or depreciate is like, the value is getting smaller. So if we see these three terms, we know that we're using the subtraction formula. If we see these terms, we're using the addition formula. Are there any questions? So what are some examples that you might have in your life that you might use interest in?
Buying a house.
Buying a house. So when you buy a house, you have to get a mortgage. Mortgage is easy. Has an interest rate on it, right? Loans. So what kind of loans can you think of?
Cars.
So there's car loans, student loans. There's, I don't know if you've heard of this, but there's home improvement loans as well. So if you're trying to do something with your house, you can get a home improvement loan, and those would have interest on it. Is there anything specific that in your life that you might have used interest rate on? What?
My cousin sold a Pokemon card collection.
So you sold a Pokemon card collection. There was probably some interest on that, right? In value. What about bank accounts? You guys, have you had savings accounts? So over time, when you save money and you keep money in there, over time you should have some kind of interest rate on it, right? What about bank accounts? You have enough money in your bank account, it should have an interest rate on there, right? So this is very useful in life, right? It's a very good thing to know. So if we're compounding monthly, what is our N? 12. What if it's daily? 365. Weekly? 52. What about semi-annually? 2. So if we're solving for P and we're doing the dividing, how do we get the decimal straight up in there without rounding?
Second, negative.
Yes, so second answer or second the negative button because that's the answer button. Are there any questions at all? No? How do we differentiate between A and P?
Starting amount.
So what's the starting amount?
P.
P, and then A is?
How much you end up with?
That's how much you end up with. So if you see a problem where you're like, after this many years you have this much in here, how much do you need to deposit? That would be what then? You're given your what and you're looking for what?
A.
You're given A and looking for P, right? And if you're given, you deposit this much in here now, how much is in here after so many years? That's what then?
Find A.
That's where you find A and you're given P. What about if, like in the last problem, we're given that a car costs this initially, what is our final value of the car? What are we given? I mean, we just gave it away. We're given P and we're looking for A. And if we're decreasing, should our P be greater than or less than A?
Greater.
Greater than A, right? Because it's getting smaller. So, I'm passing out your homework. You have a quiz tomorrow over 8.3 and 8.4. This homework, you should be able to get most, if not all of it done today. So please be working on this. If you have any questions, let me know. Does that make sense?
Yes. Heat rays. Yeah, this is it's in both of them, and you can put this one there as well.
Can I get the best?
Hmm?
Can I get the best?
Yes. So, where's gonna be A or P? Cause that could be P. But yeah, that, it would be P, right, because it says it's the Chariton, right? That's how much it's Chariton, and I put my limit value number specific here. Yes, thank you.
Wouldn't per year be annual?
Yeah, so per year, each year, that just means it's once a year, right? So what tells us to use the E formula? If it's continuously compounded. What terms are we looking for to know when to use the addition formula? Increasing. Phase.
We're gonna have a little bit of fun.
Appreciates. What about the subtraction formula? What terms tell us to use that one? Decrease. What else? Depreciate. Withdraw. Good. Remember, quiz tomorrow, 8-3 and 8-4.
We're gonna have a
Part
little bit
two.
of time to learn to like one problem.
What?
We're gonna have a little bit of time to learn one problem.
Maybe. Does anyone have any questions over today's material? No? Everyone understands it?
The last part, but I do understand it.